Okay, so we're back. We just created our existing. Time to get up. My alarm just went off too. We're starting early today. Okay, so we finished our existing profiles. We're going to go in and design some proposed profiles right now. So let's jump into that proposed design file. It has our, or not proposed, but profile design file. Okay, so the first thing we're going to do is we're going to design our mainline profile. Now the mainline profile is going to be different than the side road. The side road, we're removing the pavement, so we need to fully design that, the geometrics of the proposed profile. For the mainline, it's really just an overlay, but we'll still need a profile. So that's, the overlay profiles are handled a little bit differently than one where you're kind of defining the geometrics of a profile. All we're really going to be doing is taking that existing profile and essentially just copying it parallel, so to speak, or storing it within coordinate geometry at an offset elevation above the existing. So the way that you do that is in coordinate geometry. The steps would be you go to the element pull down, we select profile and offset, and then we select our source profile, which is the existing profile. Give the target profile a name, so we'll call it Illinois proposed, or proposed Illinois 54, and then we're going to give a station range. And actually, I think the range that's in there will probably work fine. Somewhere around the beginning of our job. Yeah, we'll just go with that. That'll be fine. And 871, yeah, that'll work. Well, let me look at the existing. How far did we take the existing? $871, yeah, that'll work. All right. So then your offset is going to be, you have to think about what you're doing with your project. The most common one would in this district, especially, or maybe all districts, we're just going with like a standard overlay, and we're going to correct the cross slope with milling. So our total overlay thickness is going to be 2 1/4 inches, but we're going to mill 3/4 inch at the center line first, right? So essentially your proposed profile ends up being 1 1/2 inches above the existing. So we take 1 1/2 divided by 12, it's 0.125 in feet. And so we've got that keyed in already. So just like a lot of the other dialog boxes, once I get that information populated, I click this add button, it adds it up here to this group, and we're ready. All I do is hit the create profile button, and you can see that every one of these dialogues, all that they're doing, in fact these dialogues didn't even exist at one time. Virtually everything really runs through coordinate geometry. Everything is a set of commands. Here, let's go to the beginning of this. You can see all it's doing for us is it's going into coordinate geometry and just automatically keying in the commands that we need to store this profile. You could have gotten the same result by going up here in the key and saying store profile proposed Illinois 54. And then I use these VPI 1, station, elevation, get to the end, and then I end profile. So really, the dialogues really aren't doing it. They're not really storing the profile for you. The dialogues are making it so that you don't have to know all the syntax of keying all this stuff in. It really made things easy years ago when that became available. And so now the profile is stored, and it's stored in the GPK file. And so we're going to go back and visualize the proposed profile just like we did the existing profile. And so I'm going to go up here to Active Chain Control and go to my mainline chain. Right-click on one, select Profile. Let's see, it should, this is View 2. There we go. So it found my profile for me. It's all in sync now. As you guys remember with this curvilinear coordinates, wherever it went, let's see, must be hiding on me somewhere. Where did it go? There it is. If this ever happens to you guys where you have some dialogue that's hidden, you're like, it just seems to have disappeared somewhere. Maybe sometimes you kill a window or something, you find it behind a window. It's hiding somewhere and just doesn't want to pop up. A couple little tricks to get it to come up for you. The first place I'd look is the Windows pull down, and it will show you all the tools that you used recently, and you just select it there and it'll force it to pop up front. That's one way. Sometimes that it won't even be listed there for some reason. So another little trick, maybe not on that one, but a lot of other MicroStation type ones, like this dialog here, how it changes when I'm in different commands. Let's say you're trying to get this drop element and it's hidden somewhere and you keep hitting it and you can't get it back. Another little trick is to instead of continuing to click there, click on some other tools first. And sometimes it'll bring up a different tool. And then once that pops up here, so the other tool, now watch, I go back and hit drop. And so there it is. So, have you guys experienced that before?
Yes.
Yeah? Yep. So it's like everything else. Why did you wait till now to tell me this stuff? I guess, well, better late than never. So, okay. I think another thing too that I think helps with losing some of these dialogues is to keep it docked. That seems to help rather than just kind of floating around. Sometimes you'll lose it that way. If it's in one location, it tends to stay there. Okay, so our proposed profile is stored. Let's see, yeah, in coordinate geometry. We saw the commands that required to store the profile, but then I can go back to Navigator and I can see what's in my GPK, and I can describe that profile. So I can see, yes, it definitely was stored, it definitely exists. Now I just want to visualize it. And so we're going to go to the same dialog that we used for the existing profile, and that is Draw Profile. And we'll select our profile name. And then remember this down here, by feature, and then we pathed out to that, or we opened up that little mini DNC manager. Unless you used it somewhat recently, it may already be available, and you can see that I've used it recently, so it's available there. So I can get to it by that way or by hitting that paintbrush. Look around. If I want the range to be different than the existing was, I could do that. And then I hit the add button. And because all I'm doing is take, every profile, just, of course, you have your vertical and horizontal geometrics. It's not, of course, you guys know this, that our horizontal geometrics, our alignments don't just meander, right? They're defined by tangents and curves. And our profiles are defined by tangents and parabolic curves. And we're going to do that. And initially when the job was designed, it included that. But in this particular case, when all we're doing is picking up the survey shots of the existing, that vertical curve length is not going to be shown or known. You can go to old plans and see what the theoretical was, but you're not going to see that and don't necessarily need that for the existing. And then as it pertains to a simple overlay project, you're not going to see that geometrics either. So with the proposed profile on an overlay job, I guess you've got the two options. One, you can either do what we just did here, and in this case you probably don't need to be showing every VPI because there's going to be a million of them. So I could just go back here and turn those off, and then I hit this middle button and it'll make those go away, because really that really doesn't really tell me too much. In fact, even the proposed profile wouldn't really even show me too much, and that's why on a simple overlay project where you don't have any earthwork at all, there's really no need to show the profile. You could simply go with a plan sheet and not even need the profile. In this particular case, the reason why we're going with a plan and profile sheet, and we're even doing anything with the mainline profile, is because we are doing some earthwork, and so we want to generate those proposed cross sections. So if we're going to generate the cross section, we want to have a profile to run those from. And so that's why you sometimes store a profile that's really just offset from the existing. So that's the main line. Now let's jump over to the side road. The side road's going to be, a little different situation. So in my active chain control, switching over to side road profile, I'm going to bring up another window for design purposes. So here's what you're going to see. This is why what you see happening with Geopak once we get beyond this point. At this point, we use Geopak, and you're essentially a draftsman, really. You're not. So far, we didn't do any engineering work of any kind. We're doing drafting, really, up until this point. But it's really when you start getting into the proposed, that Geopak can offer you a lot of tools to assist you in the design. And that's why it's much more beneficial, if possible, if the designer is able to use Geopak rather than simply marking everything up and giving it to a draftsman, because the designer can now use the power of Geopak to help you design. Because there's plenty of other drafting work to do, but in the case of trying to establish a proposed profile, you'll see here in a minute, it's so much easier to use Geopak to help you design that proposed profile. Okay, let's see. Let's bring up another window. And so kind of like we did yesterday, I kind of like the orientation to be the same, whether it's cross sections or profiles. So I'm going to take and rotate this view. There we go. Yeah, see how it's kind of in sync now?
What tools did you click to get them synchronized again?
I'm using this tool up here, Active Chain Control. And so all I'm doing is selecting the chain, and then I'm right-clicking in the corresponding window, like window number 1, right-click Plan View, number 2, Profile, and then I could have the third window up. Also, my cross-section window if I wanted. In fact, we can go ahead and do that. Let's see, we'll see what works best here. Yeah, so we'll say that's our, here's what we're going to be designing is from the edge of pavement here, to the tie-in point. And so then we'll do the same thing on the other side. Actually, let's go ahead and save this. I'll tell you what, let's save it. I'm going to save a setting so I can come back exactly to here. And we could figure out what our point is right here. We need to tie in by just doing the math. But instead, why don't we go ahead and generate the proposed cross-sections on the main line? Because when you're designing a profile, you want to know, what am I tying into on both ends? Right? So I need to know what the existing elevation is at that point, and I need to know at my edge of pavement, what am I tying into right there? Either way, the order here, doesn't really matter. I don't know. I guess I'm bouncing back and forth. Actually, while we're here, we can easily figure out what the elevation is at the proposed. So let's go ahead and just stay here, I guess. Okay, so we'll go with window number 2, get that in sync. And if you like, as long as our cross-section file is referenced, and that was our side road cross-section file. In window number 4, I can select cross-sections. Yeah. And then I'm going to go back to number 4 again, and I'm going to say cross-section navigate. And now, when I click on this middle button, you see what's happening here, right? It's taken me right to that cross section. I can see where I'm at in my profile. I can see where I'm at in the plan view. And having this really makes designing 100 times easier than if you didn't have this ability. You'd find yourself just bouncing all over the place trying to get information. Okay, so in order to figure out what this elevation is here, we know, we're going to know at the main line what that elevation is, right? And then we know we got a cross slope of 1.5% for 13 feet is the pavement. So why don't we start off with our proposed profile by just showing the main line pavement. And in order to do that, there's a couple different tools that we can use. It's up here where coordinate geometry is located. There's one called VPI-based alignment. It's basically a VPI-based profile generator. And then you have a component-based profile generator. And you'll see I'll show you the difference in the two. The second, we're going to start off with the second one, and it's almost like you're using microstation commands to draft a profile. It seems like that a little bit. The VPI-based one's quite a bit different. But we'll start off with this. So you get these tools. It looks very much like the place line, but some of the differences, it's meant to work with profiles. So as long as I'm within that profile cell, notice when I'm drawing a line, look over here on the left, and you can see it knows the length of that profile and it knows the slope. And I can lock that in. Okay, so I said we're going to start off at the PGL of the main line. So here's how I'm going to get that information. I'm going to go to curvilinear coordinates first. And I'm going to find out what my mainline station is right here. In order to do that, I need to switch this to the mainline. And that just said Kogo's required to be running in the background. And so it says, do you want me to activate that for you? And it did. That's all that did. Okay, so I'm going to snap. And there it is, 859.83. I'm just going to copy that. Then I'm going to bring up coordinate geometry. And then I'm going to go to the element pull down, select profile and elevation. there's my proposed profile. I'm going to paste that information in, and then I'm going to compute the elevation. And there it is, 620.87 is the magic number there. So then I'm going to go back and I'm going to switch my chain name to the side road profile. And so, hey Tina. Okay, so now we can locate that point using curvilinear coordinates right here. So I go into that command. Looks like place line, but it's for profiles. I'm going to come over here. I'm going to lock in that station. And then hopefully I remembered what that elevation was. Or you guys did, maybe. And I'm going to type that in. Let's see. 620.87. And I'm going to lock it in there. And then I'm just going to hit apply. Let's see. Oh, wait a minute. Wait a minute.
When you lock the station up, it looks like it's changed.
Yeah, I know. Yeah, I'll tell you what happened right there. I was trying to get the elevation, but the station that I want, that I have to use, though, when doing this is the side road station. And so what I need to do is type in 10 plus 00, because that's the equivalent station of the main line at that intersect point. And then I'm going to type in the elevation, 620.87. And now when I hit apply, yeah, so there, I'm at the PGL. And so now I know that I'm in a tangent section, so the cross slope of the mainline pavement is going to be 1.5%. So I'm just going to come over here and I'm going to set that criteria of 1.5. Oops. And I know that the pavement is 13 feet in length. So right now, no matter where I data point on the screen, it's going to draw in that cross slope just like it's shown right there. So there's the cross slope of the mainline pavement, or you could say it's the profile of the side road. And then I'm going to do just the opposite on the other side.
In that case, you cannot use mirror.
Can't use mirror. I'm not sure. Let's see. Let's see if mirror is an option. I don't think so. Yeah, that would be nice, but it's not. So looks like I'll have to go back, and I'm going to change that positive to a negative, and we'll get the other side. Yep. Okay, so now I need to tie into that point, and then somewhere over here I need to tie into my existing. So basically right there. And so what I can do, again using curvilinear coordinates, and I'm just going to use, I just need to get a reference point out there. I'm just going to use a basic microstation line command. So I'm going to use my snaps. I'm going to use intersect snap, come down here, and with my left, this probably works best with, I know most of you guys use AccuSnap. For this, I'd probably turn AccuSnap off and click on intersect. Drop down here, and then don't go right at the intersection for this particular purpose. Come back a little ways and hit your middle mouse button right there, and then come over here. Again, stay back a ways from the intersection. Hit the middle button, and it'll snap you to that intersect point. Now don't accept it. Instead, come over here, lock in that station. And remember, we talked about this yesterday. We said each one of these views requires 2 of the 3 toggles. And depending on which one of the 2 you choose, it's going to draft in that view. This is something that took me a while to figure out, and I don't know that it's documented anywhere. So it'd make you crazy if you're trying to figure out this. So what I'm going to do is I'm going to choose any elevation in the profile. And because I know if I choose these two, station and elevation, and I hit apply, it's going to draft in the profile view. And so now that line is at that exact same station. So that allowed me not to have to, write down the station and then come over here and key it in and do all that sort of thing. So once you do this a few times, you'll find out, like, you can knock this stuff. You can design. Once you guys get proficient at this, you just would not believe how fast you can actually design a project. I mean, and I think modeling is going to be the same way. I think initially, because we don't know hardly anything about it, and everything's new to us, and you're trying to figure out all these things, and it makes you crazy. Well, hopefully, we can get proficient at modeling, and then do the same thing, and make a video like this, and allow others to know this, and be proficient designers also. Okay, so we're tying into there, in there. So now this becomes probably more of a design problem at this point in time. How do you want to design your profile? There's a drafting aspect, I suppose. There's a design aspect. There's a CAD aspect. But ultimately, it comes down to two things. From a policy standpoint, what do you want to do? Do you want to do something as simple as select the edge of that pavement and come over here and do that? Is that profile acceptable? And no. The answer is no, of course, because we always want to drain the water. We don't want to drain water onto our mainline pavement. So if you look in the BDE manual, you'll see it says something, and I should have this memorized, but I don't exactly. It roughly says something to the effect of you need to use a minimum grade of, I think it's 0.75, but you'd want to check that. And you need to go back so far, which is roughly like the middle of the ditch, or I believe it also gives you a distance. Now, sometimes you have certain criteria. You have existing conditions, and sometimes you just can't quite get there. But I would say that, generally speaking, when you're designing side roads, try to make sure you're not draining water onto the mainline pavement. Okay, I could use this tool here. This would be fine. I wanted to show you also the VPI-based version. I could do something like this. I can see over here what my percent is. So I said maybe a minimum 0.75. I could do this. And then I could look here. I'm saying, generally speaking, I want to go away from the pavement to probably about where my proposed culvert is located. So that's roughly the low point, right in that general area. And you can see, if you look over here, you can see I'm roughly, 30 feet, something like that. So I guess let me show you both methods real quick. Okay, so I could do that, and then I could come back and use, we have tools in here for designing our vertical curves, our parabolic curves right here. You would normally use this one, so your tangent to both sides. And then I could come up here, let's see. I'm not seeing that whole dialogue. Let me move these over a little bit. Okay. The reason why I think you're going to like the other version is because you don't have to look up in the BD manual to find out what your K value needs to be for your particular design speed. So I'm gonna float this just for now. I'm not gonna set anything, but I could set my length or my K value. or I can leave it blank and dynamically place it. But I do need to tell it, is it a sag curve or a crust curve, which I did. So now you just select your back tangent, your head tangent, accept it, and now since I don't have anything toggled over here, wherever I place, I could get kind of a rough idea by just placing my cursor right there and then accepting it. And so there's my vertical curve. And it came up with a 35 foot. And in this case, you're so close, you're at a stop condition, so design speed is probably less of a factor in this particular case, because you're right at a stop condition. So it might be more of a matter of what vertical curve length works out well, and you do want to usually not have some oddball vertical curve length, but it looked like something like 30 foot might work well. It's and sometimes it's a little bit of a trial and error. But like in that case, maybe since, like I said, I'm at a stop condition. If you're on the mainline profile, you're going to be needing to find out what K value is acceptable if you're using these tools, and you can go with that. But here I'm almost going to disregard that for now. I'm at a stop condition. It looks like maybe a 30 foot is going to work well. And so now that vertical curve is exactly 30 foot, and ultimately that's what I'm going to want. But let's delete that now. So that was one method, component-based profile generator. And you can use a combination of the two, either way. So now let's use the other method just so you guys can see both. And usually I do end up using a combination of both. They both have pros and cons, I suppose. Okay, so I'm going to go back. Oh, where was it? Yeah, to where Kogo was, that second one over. Drop down to VPI-based version. And it brings up this dialog here, and it's asking me it needs to know what my profile cell is that I'm using. I hit identify cell, accept it. That way it populates all this information so that you don't have to do that, and just say OK. Now here, you could go through and look to see what preferences were used, that sort of thing. K-value tables. You can see that, in this particular case, it looks like we're still pointing to maybe some older tables, some 2001 tables. But we'll go with just what they have the system currently set up. I think there's an update to that, but we'd have to see. And I don't know for certain, but I'm pretty certain on when we go to modeling on their, IDOT BDE, for some reason they took the AASHTO standards and just barely changed them, for IDOT. And so IDOT had to go in and set up their own preferences. But I'm pretty certain that when we go to modeling, they're not even going to bother, with that, because the software has in by default all the AASHTO standards. So I think we're probably just going to use that. And I think the 2011 AASHTO standard is the most recent right now. I'm pretty certain, not positive. Okay, so the way that this tool works is I'm going to start off using this dynamic button. And this works left to right. So it's asking me, what is your first VPI station and elevation? So I could key that in, but I'm going to use a combination of key-ins and dynamic, which means, it's just wherever I place my cursor, it's going to go. So I'm going to be able to data point to that known tie-in station. I'm going to accept it. So now I've got my first VPI. So now I need to tell it where I need to add a second VPI. So I'm going to hit insert, go back to dynamic, and I'm probably going to start off with kind of eyeballing this thing, and then I can go back and lock it in a little differently. But I know roughly I want that profile. I'm probably going to, what I would do if I was designing this, I would probably actually check to see what this back tangent is here, and I would end up just extending that, whatever it is, to where we said earlier, using that other method about approximately where the proposed culvert is located in the middle of the ditch, somewhere like that. Then I'm going to insert, and again hit dynamic. Then I'm going to snap to that edge pavement. And then to get my vertical curve, I'm going to use these toggles at the very bottom. So I'm going to go previous. So I'm always, whatever the middle VPI is here is the vertical curve that I'm working on. And so here, like I was saying, I don't necessarily have to know that K value. I can come in and select that design speed, and it's automatically going to know what that K value is for that design speed, which is pretty nice. Or I can up it to 20 there. But like I said, this, of course, it's a stop condition, so a little different scenario. So at that point, now I can start tweaking this if I want. Maybe I want to lock in the length of the vertical curve. Couple things I could do here if I was playing around with this. Let's say I had my back tangent exactly what this was back here, and I'm like, okay, I want to move that VPI, but I want to make sure that I hold that tangent so it's the same as the existing, and it was the same here. So I can lock certain constraints like the back grade. I could lock that in. And now when I go in and I modify the second VPI by hitting this dynamic button, and I go back up, and here's the little trick it took me a while to figure out. You have to take the cursor and put it inside of that circle. So now look, when I move that VPI, see how it holds that back grade? And so these are some really, you can see, it's pretty obvious that you can see these are like some really good design tools. And so it would be ridiculous for you guys to do this engineering design work on paper and with your calculator, and then have somebody else draft your proposed profile for you when you have tools like this that are just are excellent for design purposes. All right, so that's why I think really, even if you have a squad leader, for instance, or a designer who may not know everything about CAD, to me, there's a few tools that I just couldn't imagine not having. They're just so valuable. And to me, this is one of them for sure. Okay, so maybe I like my profile at this point, and I'm going to go File, save the profile. I'm going to give it a name. We'll call it, yeah, we can go ahead and say it. Let's call it PR, maybe whatever the chain name is, S00 or S017, and it's on the south side, so we'll give it an S on the end. We'll say OK, and it says profile stored. We OK that. And so now, if I go back to coordinate geometry in my navigator, I can describe it. Not that one. I guess I selected the wrong one. Yeah. So now notice the difference on this profile compared to the other. Both were proposed, right? But on this one, I actually defined the geometrics of the profile. And one nice thing I like about this, and this is, especially when you start working with drainage, the fact that it gives you the low point in the vertical curve, that station right there. Okay. So we're good to go there. So let's go ahead and do the same thing. Actually, I want to keep moving along here. I could design the other side,
Yes, but-
it'd be the exact same thing, right? So let's just do one of each. You know, just because once you know how to do one side, you can do anything. Okay, so I'm going to exit out of here. And at this point, you could say, well, I guess I'll say yes to save settings. But once the profile is saved and it's in the GPK, and you're getting out of that dialog, it'll always ask you, did you want to save this? But know that once you stored it to the GPK, you don't have to store it again. Once it's in the GPK, it's kind of a done deal. So I'm not going to need this reference point here any longer. So let's go ahead and visualize that proposed profile. It's going to be the same steps as the existing. Oh, wrong one. Draw profile right there. Okay. Okay, so we're going to select that proposed profile we just stored. Again, change the feature over to the feature description to the proposed 20 and 5 version and add it in. And I'm not saying that's a perfect design. We threw that in there, but you saw, the tools that you would use for design purposes. It would be probably something similar to this. You would probably want to. You probably could have gotten by here. We're going pretty low. We're kind of cutting lower than maybe we needed to. You probably could have gotten by with maybe a little bit flatter slope here. It just depends on what your constraints are. Something's got to give. So when you're looking to design, what are things that you can't change, and what can't, what has to float, and you take all that into account with your final being an even number, probably like 30 instead of 32.14, something like that. Okay. So that was proposed profiles. What's next? Shapes. Shapes determine the cross slope of our pavement. So what we're trying to get to here is proposed cross sections. And now that we've got a proposed profile on the main line and the side road, we're ready to do proposed cross sections. But there is one more thing that we have to do, and that is we have to define what the cross slope of the pavement is. And normally on projects, you're going to have a curve. And so you're going to use the same tools, though, regardless of if you have a curve or not. If you do have a curve, I'll show you that Geopak will calculate your super elevation for you, your transitions, all that sort of thing. Or even if you're trying to match existing, you're going to find out from Geopak if the existing meets policy based on your design speed. And then you're probably going to end up tweaking the design speed a little bit if your intent is to match the existing super elevation on the curve. But then, even when you do that, it's always going to calculate your super elevation transition lengths and allow you to cut a cross section anywhere within that transition, and it'll know exactly what the cross slope is at that location based on shapes. So that's what we're doing now. I'm going to go back to Project Manager. I'm going to select Calculate Super Elevation. I guess I should have said no to that. And it's not letting me out. I guess I'll just hit Apply. Okay. So this is the dialog for calculating your super elevation. You're just answering a bunch of questions. We're going to need to do one for both. We're going to do one for the side road. We're going to do one for the main line. The side road, we'll probably still use this just to get something initially out there. In a situation like this, you're probably not going to end up with any kind of a normal crown. You're going to end up warping this to basically match everything around you. Yeah. Especially there, you're not going back. If we were going back further, yeah, you'd probably get into a normal crown situation. But we're really just replacing just this very short distance at the intersection. And for your cross slope of the side road, what's going to end up happening is you're going to have to store a profile. You're going to, along the edge of pavement, you're going to look at the existing edge of pavement profile. You're going to look at the profile of the edge of pavement on the main line proposed, and then you're going to design a profile around the radii on each quadrant. And so, so that's kind of fixed, right? You're going to tie into the proposed edge of pavement, and that had a cross slope of 1.5%, so that's fixed. And this is fixed on this side, so virtually every side is fixed. And so the cross slope's going to really end up it's going to warp in there. And that is one thing I like about the software we're going to. It has really good tools to deal with that. And this version of Geopak really I would say, doesn't have any great tools for intersection. And intersections are always complicated, coming up with the cross slopes and elevations. So I think you're gonna like that. But in any case, we're still going to want to generate an initial proposed cross-section, still have Geopak come up with something for us, and then we might take and manually tweak it, but at least it'll get us started. So let's generate the shapes for this. Now, you're going to want to be sitting in the geolines file, because that's where the shapes are going to be placed. Okay, geolines. Okay, so here we go. We're going to populate this. Ultimately on this short little run, actually it's down here, this little run here, you could probably type in anything for design speed. We're really not going to end up using what it computes anyway. I'm probably just going to leave it. But if you're working on a longer section and you had curves, you would want to make sure you type in your design speed. Design speed is 5 miles per hour over your posted speed. That's how you know what that is. By default, we're pointing to the 2011 standards. This is based on the table. If you look in the BD manual, you'll see that there's various tables that determine what your super elevation is going to be. So there's basically 3 tables that we use: a 4%, a 6%, and an 8%. The 4% is for urban, 6% is for rural, and then 8% really only applies to interchange ramps. So I'm just going to choose one here because, like I said, in this case it doesn't matter so much on the side road. I want to get a beginning and ending station, so I'm just going to select something before my proposed starts, and then I can see where my cross sections are, so I'm not even going to bother getting anything exact. I just want to make sure the shapes run through my last cross section on that section. And then I'm going to come over here, I'm going to hit this quick entry, and we use these shapes because we're using the criteria that was set up for us by Bentley. Shapes can be used for your pavement width and for your cross slope. We only use them for cross slope because we handle pavement width in a different way. So we're saying we've got 2 lanes of pavement, median width 0, it's undivided, and we're going to key in a nominal percent slope of 1%, but that's actually going to end up being warped. But we're just going to go with that initially. And then we have dependent shapes and independent shapes. And what the dependency is, it's upon the proposed profile. So you're going to see this shape, which looks like a microstation shape. It's going to be like adjacent to the center line. And that shape is going to get its intelligence of the elevations because it's adjacent to center line and the proposed profile. So that's what dependency is. And sometimes I'll give you an example of an independent shape. If you had a mainline pavement where you've got the mainline lanes, but then you're also adding a turn lane. So let's say the mainline through lanes are 1.5% and your turn lane is 2%. So in that case, you would place a 12% shape or a 12-foot wide shape at 1.5%, and then you would add in here you can have multiple shapes. So you'd have a shape right adjacent to the other one, and that shape you would have to say the turn lane shape. That's an independent shape because it's independent of the profile. Does that make sense? That probably not yet. That takes a while to kind of sink in. But play the video back and listen to that a few times, what I just said. And also, if you like, go to the help file in Geopak, and it'll show pictures, and it'll show you what I mean. I'm going to keep going. If we had more time, I would sketch this out and everything. But play the video back, I guess, on that one. That's a concept that takes a little while to figure out. I think maybe after we place the shape, it'll make more sense. And so in this case, when you have two shapes adjacent to the center line, now it doesn't make a difference if they're dependent or independent because both are adjacent to the PGL. But one can be independent because if it's adjacent to another shape, it'll get its elevations from the adjacent shape. So I usually just make one dependent, one independent, and then that way they end up being two different colors. I'll show you that here. So once we've gotten that far, I'm going to generate super elevation transitions. I could read through this, and you can see all the commands that are used. Again, Geopak you used to have to know all the syntax for everything that we did, and they just made life just easier with these dialogues. You used to have to type in all this stuff and have to know the syntax, and you always had to refer back to the manual. So this was a big improvement at the time. And so I'm going to hit this button. See that drill button right there? So that says create shapes. So it calculated the shapes for me. And now I'm putting shapes out there. And so I'll show you that what looks like a microstation shape with opaque turned on, that's actually an intelligent shape. So I can click anywhere within this shape, or I can even go away from it, and it will know what the elevation is on my pavement anywhere because they're intelligent shapes. Yeah, let me show you that real quick. Let's see. If I go up here, I think I can drop down and say, let's see. Looking for something that says shapes, shape manager right there. And here, I'm going to hit this information button, this analysis button. It's going to bring this up for me. And I really don't even have to type anything in here, I don't think. Let me see. If I think when I data point on it, it automatically pulls from that. So watch here. This is pretty nice with this dynamic button too. And like I said, we're going to end up warping this pavement on the side road, so I wouldn't use this from design standpoint, but you can use shapes, and you can get shapes this way through this calculate super elevation. There's other shape maker tools that are good, and when you use those tools, any way that you get your intelligent shapes, what makes it really nice is that, let's say you had an island you're designing, and you wanted to be able to pull elevations and label all the kind of control points of that island for construction so that they could lay out the island. You can actually go through, and if that island was drawn in, and you can snap to the edge of the island all the way around by hitting this DP button. And see how it's giving me the elevation right there? And then I would take that elevation and I'd have a separate detail sheet, and then I would use my labeler and I'd give a station, offset, and elevation for the island, so that in construction, when the island is built, if it's built before the pavement was done, that the construction would have all the elevations that they need to construct the island. So it just depends on the situation. I know sometimes they'll build the islands in advance of the pavement, and other times they'll actually just pave it and then go through and just saw cut out where the island's going to go. And it's probably easier to lay out that way, because then you're just matching the pavement. But we don't, in design, of course, we wouldn't have known for certain how the contractor is going to construct it, so we need to make sure we provide enough information just in case the island is built before the pavement, which it is in a lot of cases. And so it's the shapes, that help me with that. Okay, so there's my side road shapes. Let's go ahead and do some mainline shapes. So I'm going to do the same process, and that is that calculate super elevation. Use that same box here. So I'm going to say use that chain. And then, same general. Basically, I just need to go somewhere before my first cross section, end it just after your last one. I guess it would have made for a better example if I would have included this project to go around the curve so that you could see how it calculates the shapes for the curves. But it's exactly the same here. You'd treat this exactly the same whether you had curves or didn't have curves. So we'll just go with it. And so I'm going to select my proposed profile on the main line. I'm going to change my cross slope to 1.5% on both here, both sides of the PGL. And I think we're good to go. Generate this, and here it's showing me that we're in a tangent section, so it only came up with a 1.5% cross slope. But if I would have extended this into the curve, then it would have shown like where the super transition begins, and various points, control points like along that, where. I'm trying to think what the term is of those critical stations within a transition. Are they called Cartesian stations, I think?
Elevation, runoff, tangent runoff.
Yeah. Have you guys dealt with that at all? Super elevation, runoff and run out? Runoff and run out. You can take a look. There's a real good diagram of it as a CAD standard. So we actually include that in most every job, even resurfacing projects, because the way that super elevation transitions are handled is different than when the roads were originally built. It used to be based on design speed, you'd have a total transition length, and you'd take that total transition, and 2/3 was before the PC, then 1/3 was on the curve. And then at some point, 10 years ago or something, they kind of changed it. So now it's roughly, but not exactly, 3/4 off the curve and 1/4 on the curve. But there's a diagram that we have that shows the super elevation transition development in all the stations, or not stations, but critical points within that transition development. And that might be more of a design type class. I guess we're handling this a little bit more as a CAD class, I suppose. And maybe later with our group, we could maybe come back In fact, maybe you guys just go ahead and keep a running list of things in the future that you guys want to cover. You know, if you want to handle something from a CAD perspective, we can do that. Or if you want something more from a design perspective, we can address that too. And then, you know, I can try to do that for you and answer questions. And then when I'm not certain of, we'll bring in like a guest to our group. And we'll have that person try to explain whatever it is that you guys want to learn about design. Okay, same deal. I click that middle button. So now I've got cross slopes on the main line. So now we're good to go. We're ready to run our proposed cross sections. I know I'm going over this pretty fast, but unfortunately, somebody has the room at 10 o'clock, and I hate to rush through this, but hopefully you're getting enough information to at least get you started, and then if you get stuck, you know, we can talk through it at that time. Okay.
Isn't that why we have the videos?
Yes, you'll have the videos too. But I'm sure I'm not covering every last. You could take this probably much further. It's like, how crazy do you want to go with it, you know, in detail. Trying to give you guys just a good overview of start to finish of developing a project with giving you just enough information, but not showing you every single button in Geopak. Just show you all the main ones, I guess. Okay, so I'm going to go to Project Manager. I'm going to go to Proposed Cross Sections. I'm going to exit out of that because last time I was in this, we were developing the existing pavement from this location. So I want to go back to it and create another run. So we'll call that Proposed Illinois 54. And we've already been through this with the existing, so it's about the same thing with the proposed, right? So I'm going to path out to my cross-section file. So we're doing mainline right now. So there's mainline. I think we need to change this to 0.01. Pattern lines. I'm going to select my chain. 2 to 1. Geolines. And I'm going to toggle a few of these. I'm going to match my pattern lines. Existing ground. Probably need to be sitting in my cross-section file for that. So mainline cross-sections. Okay, so I'm going to point to that file. Match the existing ground. The reason why it needs to know that, because if you think about it, like the back slopes, you know, they're going to draft up until they hit the existing ground. And so that's just why it needs to know what level it's on and all. Okay, shapes. We just did this. We just placed the shapes in the geolines file. Next is shape clusters. So what you do here is you hit the scan. We didn't do this last time with existing, remember? Because we didn't have shapes. We were shapeless. Yeah, I know it sounds goofy, but okay, so I'm going to hit scan. It's going to show me my clusters of shapes. So we created a cluster of main line and side road. So there's the main line. So it automatically populated my chain in my profile. Remember, we add that in, we select it, we click on typical. Just like we did with the existing, we can look through and find the typical section that looks most closely matches our situation. Now, having said that, you can do that. These all work fine. And they all have really good directions on how to use them. Whichever one that you select, you come over here, see where it says description. And the guy that wrote the criteria, Chuck Lawson of Geopak, apparently back in 2006, he initially wrote it in 2001. So you can see it's pretty old, but still works excellent. And it'll tell you every file that you need. It'll tell you where things need to be drawn. Remember, we said some things we need to use the DNC manager and tag them, not just have the attributes of level, weight, and color. These files, like I said, did a really, really good job of, this one's a real basic one, but giving directions and telling you really everything that you need to know. You will like that for sure. Now, I was just saying that you find the one that you like, because there's a million different scenarios. Now, I'm going to show you what I do. I'm not going to say this is the absolute right thing to do. This is a way to handle proposed cross-sections. I treat everything like it's new construction in regards to the typical section I choose. There are widening there's ones that are specifically for widening or for most any situation that you can find. I just found, I guess, over the years that no matter what you do with this, that this system is like really, really good for automating 80% of your cross-section of the work. And it seems to me like no matter which one of these you choose, you still end up manually drafting about 20%. And I know that this one, new construction, works really well. And I know that even though the main line, I'm not replacing the pavement like I am on the side road, because everything's on its own level, I can go in and, with the click of a button, delete the pavement. That's what I do. Like I said, do whatever you want. All these work fine. This is a way. So I'm going to show you how I've done things over the years. I'm also, this also makes me think of modeling though, because over the years I found it easier. I had to be, as a squad leader, I guess, most efficient in everything that I did, because as a squad leader you end up getting more and more and more and more work as time goes on, and you're always chasing that. You're always trying to meet letting dates, and I never did anything for the sake of automation purposes. I did whatever it takes to get the job done that was most efficient, and for me it was usually to run this one time, automate the cross sections one time. And then I would go in, and with active chain control, that's really powerful, I could tie into any existing situation and knock out a job, really quick. One thing, though, that I'm thinking about now is the fact that modeling is not like that. You really can't do that in modeling. And so our thinking's going to have, my thinking would have to be different when we go into modeling. You have to think about automating everything that it is that you do, because there is no ability to manually draft anything. Although there is one thing that gives me hope with it is I did find out there is an ability to kind of manually do some 3D drafting in the model. And really the cross sections are just going to be visualizations of the model at any location. And so I think in a sense, even on modeling, you are going to do some manual drafting, but not not manual in the sense that you're manually drafting the cross-section, manual in the sense that you're manually doing a little bit of work in the model. And then all of those models together will be published into, all those terrains will be published into one model. Okay, so just like yesterday, I'm going to hit apply. And that's just copying down that criteria. And then I'm going to go through and I'm going to answer all these questions in design variables and redefinable variables. I'm going to select cross-section. Again, mainline, modify. Topo. My design file. Always hit modify. The right-of-way file. And remember, that's in the land acquisition folder. And in this typical actually works. Remember yesterday I said it was having me choose that file when I knew it wasn't really going to draft the right-of-way for me there. But I guess all the variables were just kind of mixed in together. So Geopak lines, that's where my pattern lines are located in the geolines file. Hit modify. Plan view ditches, this does have the ability, I don't use this a whole lot, but if you like to, in addition to automatically drafting in the cross section, it'll automatically also go back to the plan view and draft in your ditch bottom for you. And that's the reason why it's asking me, where do you want me to draft in your plan view file? And as I process this, it's going to give me the option of saying yes or no, I want it to do that or not. Now, we haven't stored any special ditch profiles yet, and we'll come back and do that here in a minute. But right here is where I would specify the names of those special ditch profiles. So the way that it works is it's going to go with a standard 3-foot ditch on all my ditches on my proposed cross sections, unless it's within the station range of a special ditch profile. You know, a ditch bottom that varies. It's not a constant 3-foot. And then it'll do all sorts of other things too, and I'm not going to get into this so much because once you know how to do what I'm showing you right now, you could really do anything with this because it's all kind of the same. You know, just like we drafted in edge of pavement, if there was curb and gutter, you know, I would have drafted that in. I would have tagged it. Right-of-way lines, everything that you draw in that's available here. And when you're using this typical, I'd highly recommend you print out, hit that description button, read the instructions, and you'll see all the things it's capable of doing. You know, if you have an urban job and you have sidewalks and you drew that sidewalk in, it will automate the process of drafting the proposed sidewalk with the cross section. Like I said, curb and gutter, swales in between, like the curb and gutter and the sidewalk. It'll do everything that you're going to see here, you know, plus more. And again, we just answer all the questions here. What is your surface course thickness? You know, by default, it's 1.5 inches. Good. What's your binder course thickness? 2.5. You know, more commonly, a policy overlay. You know, probably 0.75. But on a lot of projects, including this one, because this is a real-life project, they actually, our material section, I know, did give a pavement recommendation of going with an extra thick overlay. Isn't that right, Clint? Yeah. What was it, like 2 or 3 inches on the binder, maybe?
Oh, it was like 1.5 inches.
1.5 inches?
Yeah, I can't remember.
Yeah, probably 1.5 inches and 1.5 inches. So your total overlay thickness was maybe 3 inches instead of 2.25. So we'll save that. Base course thickness. Now the base course thickness isn't going to matter here because we really don't have base course, right? It's going to drop, but we're going to delete it. Like I said, this is a new construction typical. On new pavement, you type in whatever your base course thickness is, probably somewhere around 9 inches. And then sub-base. That's going to be normally an ag sub-base, usually 8 or 12 inches. Or it's going to be like a lime modified soil on, like, say, new construction on a rural section. And that might be like 12 inches. But again, we're not using that in this case, so I'm going to end up deleting those, even though it's going to draft those. We'll just, I guess, leave that as is. I might go up here and change this to my proposed cross-section level. Let's call, I don't want to look too long, but pavement surface. And by level, by level, by level. Okay. Okay, now we're going to save the run. So we are ready to process some proposed cross-section. So if I keyed everything in right, it'll work, and if not, it'll give us an error message. So we'll see what happens. So it's asking me here, it's definitely going to draw my proposed cross sections, but do you also want it to go into the design file, the plan view file, and draft in that 2-foot ditch bottom for me automatically? I usually end up saying no, and the reason is because at this point I know that I'm probably going to need special ditches, and when I do that, it's going to change the offset of the ditch in the plan view. So I'm going to say no. Let it process the cross sections. Okay, and I'm going to exit out. The reason why I looked first was because if I saw any major problems, I was going to hold off on exiting. And then sometimes if you miss something, you can go back up and it'll tell you, hey, I can't find what, this, maybe I typed in the name of a file it's pointing to incorrectly or something. It also created a log file too. So if you ever get to the point where you just can't figure out what you did wrong, you can actually, there are a couple things that you can do to figure it out. You could go to where that log file is, and then you just look through it, and it'll tell you what the problem is. The other option is, while I was processing, it gave me the option of like reading the criteria viewer or something like that. And so I could have actually let it run through all that text, and you can actually hit next. So it's reading every syntax that it takes to do this. And it takes a while because there's a lot to go through. Go next. But I could see every single thing, and ultimately I would be able to figure out what the problem was. Let's see. Before you use active chain control, well, I'll show you that. Navigator first. You can use either one. We can toggle through. Ultimately, like I was saying, this isn't new construction, and so see that base course there and that extra line there. I probably even wouldn't worry about this yet until I get my ditches and everything squared away. But at some point when I'm getting ready to kind of finalize these cross sections, I'm probably going to bring up my levels, and a couple ways I could do it. One way would be to make my active level, that base course level, say all except for that. All off except for that. Yeah. So there's all that base course that I'm not really doing. I can just delete it. Now when I go back to my cross section, I'm just seeing the overlay, surface course, and binder. You can see that, it's we're doing cross slope correction also because it's not following the existing cross slope. Like some of those other typical sections, they would say match existing cross slope, and maybe there's other districts that work this way, but I don't know. I've worked in 2 districts now, and I can tell you, every single project I've ever worked on, we've milled. I can't think of any project that we didn't mill. So we corrected the cross slope. So I've never used the other typicals that say just match existing, but if you ever have that scenario, then it will actually go out and look at the existing cross slope, and instead of using the 1.5%, it'll just put back what's there, just match it, and you might end up with a little bit of cleanup, like, I just usually figured that was going to happen. There's always little things for cleanup purposes. I usually wait to the very end to deal with that. That's minor. That's like nothing to make it look pretty, basically. The reason why we have cross sections, sometimes we get caught up in too many details. Sometimes you might think about, from a design perspective or construction perspective, why do they even need cross sections to begin with? What are they going to use it for? And number one, well, I'd say the 2 most important things for cross sections are number one, develop construction limits. Determine how much right-of-way that you're going to need, and of course where the back slope ties in with the existing, that's the construction limit. And so as I go along, and once we establish our special ditches, you might find that you'll get into situations like this where I'm extended beyond the existing right-of-way, so I need to buy right-of-way. How much right-of-way do I need to buy? And so you can go back to active chain control, and just like we did with the cross sections, and you can actually draw. You can have this. There's a way to automate the process of have it doing your construction limits for you, or I usually end up doing this myself, just using active chain control. I'll snap to that point. I'll be sitting in the plan view file. I'll snap to that. I'll lock in station and offset, and then I'll have it automatically draft in my construction limits for me. And then from there, you can take a stab at designing your proposed right-of-way. Because in this district, that's the way Land Act operates. They have us for, they may tweak it, but they want us to take a stab at, how much right-of-way do you need? Because you're not just going to follow the construction limit. You're going to come up with something that it includes the construction limits, but is at some nice even station and probably a nice offset, and it's a straight line, that sort of thing. And again, based on time, we got about 45 minutes left. We don't have, and I'm going to try to get to the end. So I think instead of reprocessing at this point, since we kind of covered it already, remember how we locked down the existing? So at this point, what I would do, I would look at the initial design, and I would say, okay, is this about what I want? And it is. It's something close. May not be exactly what I want, but it's about what I want. I know I can't go with standard ditches because I know from a drainage standpoint. Remember on this job, we're trying to get from that intersection down to that swale. So I'm going to need to look at the elevation at that intersection, the elevation down at the swale, and then somehow I need to either have a straight line profile or a profile with maybe a few VPIs in it. I guess we could jump into that real quick. I'm not going to reprocess, but I guess maybe I could show you quickly how I would go about designing a special ditch profile. And then once I did that, I would delete everything here and keep the existing, it's locked down. And then I would type in the name of that special ditch profile in that redefinable variable and just hit run. It'll reprocess again, and then this ditch bottom, rather than being 3 feet deep, it would be the depth of my profile at that location. So yeah, let's go back to profile for a minute. Sync up my profile, number 2. There, actually, let's look at the main line. Now, another reason why I'm doing plan and profile sheets is that I want to be able to show my special ditch profile. So in addition to having cross sections that have the proposed depth, of the ditch at those locations, that's a place where I could pull the elevation later. I also, in my plans, want to show the special ditch, the profile of that special ditch. So in window 1, let's go to plan view. And then window 4, yeah, cross sections would be good. Okay, we had side road, but I guess I didn't have main line. Okay, let me just grab this real quick. Here, ultimately, here's where I need to get my water to flow to, this swale right here. And so my special ditch profile, the low side of the special ditch, is probably going to be somewhere right around here. I'm going to be tying in probably about right there. So using curvilinear coordinates to do a little research here, I guess. I'm going to say, I want to tie in about right there. So I'm going to want that reference point over here. So I'm going to toggle that elevation, end station, hit apply. And so right there, that's what I want to tie into, right there on that side. Now, let's run up here. And I would have had to have developed this a little further, of course. But once I got that proposed crossroad culvert in right there, then I would take the invert of that culvert, which is going to be roughly, like, it's not going to be much deeper than the exist. It's going to be somewhere around there. I mean, it's going to look something like this. I'm going to end up with you can imagine this. And that's going to be 30 inches times 2 because the cross section is exaggerated by 2. So like that, roughly right there is going to be the invert of my crossroad culvert. And so I would put myself a reference. So I'm going to snap there. And then again in the curvilinear coordinates. Okay, I'm going to snap there, station, elevation, there. So just like designing a roadway profile, you always have constraints that you're working in. I know I need to get from here to here. Now, what's that going to look like? And you almost always start off, well, what happens if it was just a straight line? What's my percent going to be, my grade? because I know that anything over 3% is going to cause erosion, right? So I go there, and it says 0.66, and I can deal with that. So it would be a done deal. I mean, I'll just go with that. And so then you would need to get that special ditch profile stored into coordinate geometry in some way. And so I've been having a little bit of problem with this recently. I'm not sure what's up with that. I need to look at this. The component-based version that store vertical alignment. Let me try it. There's 3 ways you can store profiles, so if it doesn't work, there's plenty of other ways. Let's see. So it's going to ask me the profile name. And then I'm going to accept. Yeah, that's what it was doing before. For some reason, I haven't been able to select it. So instead, let's go back to that VPI-based version for now. Identify the cell. And again, just hit that dynamic button. Insert a second VPI. And save the profile. You probably call it like special ditch left or something like this, or right, I guess in this case. Okay. Okay. So now that special ditch profile is stored in the GPK file. I'm going to exit out of here. I can say no because the profile is already stored. Go back to your draw, not ground profile, but draw profiles. So I've got my 2 roadway profiles. Now I want to add in my special ditch profile. So just like with the roadways, I'm going to select that profile that I just stored, special ditch right. I'm going to drop down here. I'm going to see if I have any special ditch, if I used it recently, and I guess I did not. So I'm going to hit this paintbrush. It's going to take me to that mini DNC manager. And this time, instead of existing ground profile, I'm going to select ditch profile and proposed and right and 20 and 5. And I'm going to add that in. So there it is. So my special ditch profile is now visualized and drafted to the IDOT standardized symbology that you'd find. Have you guys ever looked in the highway standards, that 000, the abbreviation one? And then it gives you the symbology for everything that we do. And this is one of them that you'd find in. This is just IDOT's way of defining a right special ditch. Everything has its own symbology. But fortunately, you don't have to memorize any of that sort of thing because we just went to the DNC manager. Somebody had already taken care of that for us. We just said, hey, this is right ditch. And like everything else, it said this is the symbology that you'd use for the right special ditch. Okay, let's check our list to see how we're doing. Okay, so we did shapes, we got proposed cross sections, we got special ditches. I guess we got 2 things left and we got about 30 minutes. So I'm determined to get all the way through this for you guys. So I know I'm rambling on. Usually I wish I would have stopped and just had asked questions, had some involvement, because I know it gets old listening to my voice for a long period of time, I'm sure. But let's try to knock it out. Then that way you'll have it on video. You can go back and play it later. Okay, so we have our cross sections in our cross section file. But now you want to put them on sheets. Okay. Yeah. You know, you've got the cross section. They're on a cell. So what we want to do is, in a separate file, have our sheets file, you know, with our grid and all that good stuff. And then we want to take and we want to reference each one of these cross sections onto the sheets. The reason why we want it to be referenced is when we come back later and we make changes to these proposed cross sections, that change automatically reflects on the cross section sheets. Just like I know most of you guys have set up plan sheets before, or plan profile sheets. And it's the same way. You don't. People have a tendency to want to copy things in, but if at all possible, only reference it. That way, when you make changes that persist, through the other files, and so you don't have to do additional work. It just automatically happens. And so the way that you set up your cross-section sheets is in Project Manager. There's a cross-section sheet dialog. And like everything else, I should mention this, it's always going to do this. It's going to say no sheet. You're going to think something's wrong, but really, just hit OK. It's been like this forever, and it eventually opens. I don't know why. But it consistently will work fine, but it will also consistently give you that message. Okay, so it's asking me the question, where are my cross sections located right now? So I'm going to point to that file. It found, because it's in the cell, it knows automatically what the chain name and the station range is. So it's going to give you every cross section if you want, or you can key in a range. Then it's going to say here, now unlike the plan and profile sheet generator where it automatically creates a DGN file for you, this one you have to have an existing sheet set up already, an existing blank file. So if I go to my CAD Sheets folder and look through all of my template to see what's available, hopefully there's a cross-section one in here somewhere. You're kidding, there's not one there? Traffic signals.
Typical section. But
Yeah. Huh. I'm going to have to go back to our main template and add that in. Yeah, I don't know why. That's missing. Well, let's just take one that's out there right now, and we'll just rename it to cross-section. XSEC. Maybe main line. We'll say OK. OK. So let's go back and we're going to path out to that Sheets folder. And hopefully, do we see it anywhere?
yeah, down
Yes.
the bottom, almost at the
Yep.
bottom.
OK. OK. So that's where we want, and it's going to ask us, what sheet do you want me to use? Do you want the horizontal version or the vertical version? I thought maybe the picture changed. It doesn't. You know what I mean? Do you want the sheet to be, what, landscape or portrait? So horizontal is landscape. So we'll go with that. And 5 works for most everything. Sometimes your cross-section is just way too wide and it won't fit on a 5 scale. You might have to go 10, but mostly 5 works. So I'm going to select 5 scale horizontal. And then it just has some information. You don't have to do anything here about the sheet cell that it's going to use. And then by default, it says it's trying to determine, like when I create a reference file, how far out do you want me to go? Because it's going to look at all the elements drawn within that cross section, and it's going to go out to the furthermost one that you have the level selected. And so by default, we've got all the cross section levels selected, or the main ones anyway. So that should work. sheet stack orientation, you don't do anything here. You want just a single stack, go with the defaults. Margins and spacings. Once we process these, you'll find that sometimes you need to play around with these. It'll try to fit as many cross sections as it can per sheet, but sometimes you'll find that you just don't like what it come up with. It's trying to fit too many on a sheet or something, and you want to increase the spacing between the cross sections, and then that'll force it to get the number of cross sections that you want. It's asking you, do you want us to put the stationing information and elevations and all that? And we say yes. Elevation, sometimes if you got a really, really flat cross section, it doesn't put enough elevations out, so you can hit this add, and it'll force an additional elevation out there for you. I really haven't used this for earthwork quantities. It's possible to make it happen. The drafting has to be absolutely perfect and everything on the exact correct level. I found it easier myself to do this on my own using the flood command or create region. Have you guys used this command right here before? Never? Okay, just being, I'm saying we're not going to use it here. Let me show you another way that I personally think is better for what we do. Anytime that you have like something like this and you want to calculate basically that volume, like imagine this is the cut section on a cross section. This create region is very good right here. And I'm just going to set my fill, and I'm going to click flood, and I'm going to data point inside that area and hit apply. And if in my view attributes, as long as fills was turned on, it automatically fills it in. And actually you want to hit keep original too, so it ends up like this. And so then what I do, I just run through my cross sections using Navigator or Active Chain Control, and it's that fast. You know, it's like, and then I get my cuts, I get my fills, I go back through the IDOT menu pull down, and I use this measure area. Tina likes this one here. Right, Tina?
Yeah.
She's been using this in the plan view.
All the jobs they give me, I have to use it a lot.
Yeah. What this does that the MicroStation version won't do is this. It allows you to have multiple shapes, and it will add the shapes together. So like on your cuts and fills on cross sections, you're going to end up with multiple shapes, multiple cuts and fills, but you want to label the cross section as the cuts and fill in square feet on what your areas are. And that's the adding all those shapes together. So let's just put two out there real quick, and I'll show you what I mean. You'll find this tool useful in a lot of areas when you're calculating quantities, not just cross sections. And so the way it works is I click the first shape plus that shape and place text. Of course, I would set up, you know, my text size and all that. I'm, you know, way too big. So once my text size was set up, so it's and then I can come into my, I can go to preferences, because if you read in the BD manual, it'll say we show cuts and fills to the nearest square foot, so you can get rid of the decimal places.
Is that automatically correct for the scale?
For what?
The scale, you're exaggerating.
It does not correct for the scale. So what you need to do, that's a good point, Brian. Yeah, because you could end up quantities way off twice as much. Remember, we exaggerated the Y. And so what you want to do, what I normally do, you got two choices. You could either go with what you have here, and, you know, well, here for example. And sometimes what I do, I make a copy and put this on top of itself, because and I'll lock these down. I'll put a copy so that I can do things like I don't know if you guys have calculated cuts and fills or not before, but let me just give you a quick example of what I'm saying. What I would have to do here, the cut, because they're calling for topsoil, which we really don't too often, only in new construction. But if you were, your cut would actually go down to the bottom of the topsoil, right? But then you know that the cut is paid for to the bottom, but then you're going to come back and you're going to pay for the topsoil separately. So what I might do in a copy, sometimes I'll do this so I can just get the shape one time. Several ways you could do this here. I could either flood the whole thing. Where'd my create region go? I could either do that. And I'll get back to your question, Brian, about the...
I know how to do it.
Yeah, you know how to do it, yeah. You're just making sure I don't forget to tell them, right?
Yeah, well, I was wondering if it did it automatically. You already entered the scale.
Yeah,
Cross section.
let me hit undo on that, and then that'd be one way of flooding that. But getting back to Brian's thing about that, here's two choices. You either take all the cross sections, if they were selected. I could take this back to a 1-to-1, right? I could go scale, and maybe you do this in a separate quantity computation file. And I could say, I could unlock, and I'd say keep my X at 1, but make my Y 0.5 to get my 2-to-1 back to a 1-to-1. And then see what it does. It would take it back. Now you could use regular microstation commands if you wanted, and it would be a 1-to-1. You'd just flood it. Now here's what I would probably do instead, just like what Tina did the other day from square yards to, she wanted square yards, and it gives you the working units, which are square feet.
Yeah, they wanted me to switch it to yards.
Yeah, so what you can do, just like you did in the plan view, you can do that with cross sections. You go to the preferences, into settings, and I would say for a conversion factor, and this seems backwards, by the way, but do a little test run on this. But I would type in a conversion factor of 2, although it seems like it should be 0.5, but it's 2. And when I do that, and even though that it's exaggerated, I guess what it's saying is what did you exaggerate it by? I exaggerated it by 2. And so by typing in 2 here, when I flood that area, it would automatically, now see how it's half the quantity? And so that way, if you did the conversion factor, you would not have to take your cross sections and scale them back to a 1-to-1. You could leave them at a 2-to-1. I come to trust this. This works really well. Now, same with what Tina was doing in the plan view the other day. She set that to a 9, I think, was it? Let's see. Let me think about that. We were going from square feet, square yards, whatever the conversion factor was that worked for that. We set that, and that got her square feet. Okay, I want to keep going so we finish on time. Okay, we were in the process of placing our cross sections on sheets, and I just mentioned that as long as you draft everything perfectly, you could use this, or if not, you could use the manual way, like I was showing you. And then we have separate Excel spreadsheets that are set up for cuts and fills. So you trust me, this is probably the way to go. Use this command. Click, 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 click. You get exactly what you want because you know yourself how you're paying for things. The problem is Geopak may not have quite enough information. It might not realize that, oh, wait a minute, we normally pay for topsoil with a square yard pay item that has a depth of 4 inches. In this case, it's a different situation, and there's other pay items that we're basically going to strip the topsoil on the job. and we're going to only pay for it as like topsoil excavation or some pay item like that. I forget exactly what the pay item name is, and you're paying for it differently. So you as a designer know how you chose to pay for everything, and so because of that, it makes it really hard for Geopak to get it perfect. So I would recommend doing it this way yourself. And then afterwards, you go through, you got the numbers, you got the cuts and fills, you key in that Excel spreadsheet. From that, you create yourself a schedule, then you send to construction, just like you do with all the other quantities that you calculated in Excel, and you email to construction that Excel spreadsheet that includes all the cuts and fills and how you computed your earthwork quantities and other quantities. Okay, so we'll go with this, go with the rest of this. I'm going to save the settings and lay out the sheets. It's going to take me to that cross-section sheet file that already exists. It's going to reference in every one of those cross-sections. It's going to take a stab at putting the right number of cross-sections per sheet. Sometimes it works the first time, sometimes you have to tweak it. Let some levels are maybe turned off. Let's see. I see what I did. I thought maybe I did that. What happened here was that, remember I said by default the levels were set, and then I went and clicked on something. I didn't click on all the levels that make up that cross-section, so when it created the reference files, let me zoom out a little bit, it didn't go out far enough. You know, all that is really there. It's just that when it did the clipping, it missed it. And so, you know, at this point, I guess what I'd do is I would go Tools, Detach All. I might even be able to do Undo. Oh, no, I didn't want to do that. Let's redo. And then I'd delete the sheets and everything. I'd go back to that proposed cross-section dialog. And I know this is where it went wrong, was not this dialog, but the cross-section sheets version. At some point it asked me what levels everything was on. Which one was it? Criteria, yeah. This one here. And so let's see, let's do this. Okay, I guess I should have done this. Remember how we matched up everything before? I'll just hit reset. And I just want to make sure that I'm picking up on levels that are as far out as possible, because it's going to go to the outermost one. And as I am hitting a match here, see, it's grabbing all those levels, so I should be good now. And so then when it clips the reference, it'll go at least to that bottom text and then up here. So now when I hit layout sheets, it should be good. Yep, all good? Okay, final stretch. Now the next one, I think probably most of you guys have already, we'll run through it in case anybody has not, or for the sake of the video, I guess. Setting up plan profile sheets. Has anybody not done that before? I think most of you, Clarence, have not yet. Okay. Well, we will cover it.
Two new hires.
Yes, and the new hires. Okay. The way that works is in the design folder, in the template, there's a file called layout. So we're going to go to the layout file. And what this process is going to do for me is it's going to look at all my files in kind of the strip map version, and it's going to take and place windows, basically a window into those strip maps, and it's going to reference that window into the sheets file. And we do that by placing every file that we want to ultimately end up in the sheets file. We want to make sure that that's referenced first to this layout file. So we go to Reference, and we select every one of those files. So that's going to be alignment, the design file, which is the proposed, the image, even though we typically go with the image, even though that we don't normally use that on the final, but sometimes we do. It's useful. Topo and a profile. And the only one I really need to tell which model I used was alignment. The rest are just, there's only one model within the design file. Okay, so there are all the files, and also if I was to zoom way out somewhere, I'd see there are my profiles. But first, I'm going to place windows here. It's going to be kind of like this. You know, we have sheet cells, plan and profile sheet, maybe in this case, 20 scale. So that's the size, you know, it's going to ultimately, we want it to ultimately end up looking something like that. And like this. But in a separate file and referenced and all that sort of thing. Okay, so the way that we get there is we go up here in our Geopak Road Tools and select Plan and Profile Sheet Composition. We open up a run, and we go over here and we find the one that we want to use. Is it just a plan sheet? Is it a plan and profile sheet that has overlap, which we don't normally do? Or one with no overlap? Is it the urban version, which the urban version has a small profile and a big plan view? Or is it just the regular rural version? And that's going to be this one, and there's a short and a long version of it. Let's see. And then we also want to pick the grid. Remember, and when it says grid, it's referring to the vertical. Remember, it's a 20 and 5. So I'm going to click one plan, one profile, 5 grid, no overlap. Let's see if that one works for us. And then here we had to tell it 20. If that was different, I'd want to say 20 scale. I click over here, and it says when I clip this reference file, do you want overlap? Do you know, inside out? It's got a couple different versions. We always use the radial version, which means it looks like it looks here, where the clipping is perpendicular from the alignment. And then I click the next button, just kind of go down the tools to click each one. oh, first time that, sure, it happens at the very end. Gee. Maybe that's good because when somebody's watching this video back, they would be like, wait a minute, that's not true, because you know that it's not that uncommon to get knocked out of. I'm very surprised it took us until now to get knocked out. So if for whatever reason it didn't like something I did and it's going to lock you up, I can see what happened now. Because I had that all of our dialogues docked over here, it probably didn't like the size of that, and you can see how it's over here. I can't really do anything with it. That's a guess. Maybe it didn't like I had the sheets. I'm not. Sometimes you just don't know why it locked up, but you're just like, okay, I want to get out, back in. So what I always do is I go way over here in the bottom right, and I hit show desktop. That way I don't have to keep minimizing, all the windows. And then I quickly find what is located on most all of our machines, and that is a icon called Kill Bentley. And what is it? What product do you want to kill? We want to kill Geopak. And that just instantly, it's the equivalent of going to, what is it called, Task Manager, and finding the right process and killing it. It just allows you to quickly kill it, get right back into it. But we're just going to go down the line. We said, okay, here's what we want to use. We need to give it more information. We need to say, we need to tell it this is our alignment. This is where the profile cell is located. This is the width of a sheet. Maybe I've got a station equation, and I've got one sheet that needs to be shorter than the rest. All that sort of thing. So while we're waiting, I guess any questions? Anything you guys want to talk about?
It's a lot of information.
Did I go? Probably went too fast this morning, didn't I? Because yesterday, we didn't try to rush it. I think we went at a good speed yesterday, and came in knowing somebody has the room at 10 o'clock, and so I had to go the speed it would take to get us finished.
I could probably put a slow motion on the video.
Yeah, but I'll be talking like that. Yeah. We'll see. And if we have to, you guys play this back, see if you can, if it works for you. If not, we can redo the video, and we can recover what we covered this morning, because I know we sped it up, but with the video though, hopefully you can go back and just pause on each thing. We do one thing, okay, stop. I think you'll just be hitting pause a lot more, but hopefully, I think I said all the same words, but that I would have said otherwise, but maybe just faster. And so when you hear it all at once, it's a lot to take in. I can imagine. Okay, so I'm going to go back to Project Manager. I think I'm going to undock that. I think that may have been what caused the problem. And we were doing a. Can we get to it from here? Yeah. Okay. Let's go back to this. Yeah, it's still in the radial version. Okay, that's the dialogue that died. Okay, so it's asking me for 3 questions here. It wants to know, what alignment am I using? So I'm going to double click on alignment, and I'm going to tell it E001 for the main line. And then I want to bring up my profile. So going back to active chain control, I'm going to use that to quickly get me over to my profile, which is right there. So I'm going to double click on profile, and the reason why it needs it twice is because it's going to reference in first the profile itself, and then it's going to reference in the tabular data below it. And what that does is it allows us not to be concerned about the spacing here. Like when you have multiple sheets, you'd have to have variable spacing. So instead, the way it handles it is it just referencing the tabular data separately. So I'm going to identify the cell and accept it. And then I'm going to go to the tabular data, identify cell, again, same exact thing. And I know I need multiple sheets, so I want to switch that to multiple sheets up there. And then let's see, on my range changed. So let me go back to the plan view for a second here. And let me specify that range. I don't know that I ever did that. And I know I want to end up with 2, so sometimes I just kind of play around with this a little bit. Now, you're probably going to want to start off on a nice even station. And so there we go. So I'm going to hit layout 2 sheets, and it hasn't cut anything. It hasn't done anything yet. It's just telling me if you cut the sheets right now, this is what you're going to end up with. And I'm not going to want that sheet in right in the middle of the intersection. And I know my project really only starts at this culvert. So I can see that I can shift everything to the right a bit. And so I probably want to move over like at least 100 feet. So how about if we change, yeah, we're gonna move these. I could either replace them or I can move them. This tool right here allows me to modify sheets that are already out there. And so I'm going to identify that first sheet, and I'm going to change that beginning station. And because slide following sheets is toggled on, when I hit apply, everything should move here, and in the profile. And so I like it. It's good to go. Sometimes you might even have to move it like up or down, and you can do that dynamically. Again, first just ID the sheet that you want to change. You can hit this middle button here, data point anywhere on your screen, and see how you can tweak that a little bit. Like you're like, okay, I don't want it dead center. I want to be off a little bit because I missed picking up something. I really wanted it to be down a little bit or something like that. That's very common. And I'm good to go. I like my borders. I'm ready to clip. So I'm going to hit this button here, clip sheets. And I want to make sure that I'm pathed out to the right folder. In this case, it was in miscellaneous, training, class demo, data, and CAD sheets. So it's actually going to be creating the DGN file. And I want to make sure it puts it into the right file. Now, it's automatically also going to name it partially, but you can still key in, and you can rename this later, but remember, we always use our same, being we're not using the template, we want to make sure we're using the right file naming convention. So we're going to go D672, or whatever our contract number is, dash, plan, sheet, or whatever the right file naming convention. And then notice when I hit tab, see, it shows me over here the file name it's going to give it. Even though, like I said, in project-wise, you could change it later. We'll go with that. And then it says, okay, maybe you've got 20 sheet cells out there. What range do you want to use? Well, we really only have 2, so we want to start with 1 and end on 2. Maximum of 16 per sheet. In the district, we operate a little different than consultants. Consultants usually put one sheet per file. We put all of our sheets in the same file, and because of that, we need to use rotate reference rather than rotate view. It's automatically going to put the text out for match line, so I'm going to type that in. Match line space STA space. Then I won't have to do that later. And I'm ready to go. I'm going to hit Process Sheets. It's creating the design file. It's referencing everything that I need. So you just sit here for a few minutes. And this is something you could have done manually. You could have gone in and there's a handful of people that prefer to just do it manually, like Mike Whitling, if you work for him or with him. He may have you use this, or he may prefer that you do everything manually. I like to use this tool just because it seems to work well, and it does everything I need it to do. You know, it creates the file. Well, you can see what that's a lot of work to get to that point manually. So, I think Mike's been doing CAD for a long time. He's very proficient. He can, you know. He can do a lot of CAD work real fast, so he's like, well, I can just do that manually real quick and get exactly what I want. Maybe sometimes, anytime you automate something, you're sometimes a little bit limited. But to me, this works very well. And so if I go into the Sheets file, I can see there it is. Let's take a quick look at it. We got just a quick preview of it. But let's go check it out, make sure, work for the profile as well as the plan view. And we can see it did. Worked just fine. And we'll wrap it up there. Of course, we can take plan development so much further, and maybe we can do that in future videos. Other things like Tina mentioned the other day, hey, what are some basic things you need to know about setting up plan sheets that you do on every single job? She said, hey, don't forget the north arrow. And there's easy ways to do that because this changed our orientation, right? It rotated the reference file. And so, little tips and tricks would be good to know, rather than to know what the degree angle is on your north arrow. Instead, forget that. Go back to your layout file or your design file. Go to your IDOT menu, pull down, select north arrow. North is going to be up there. Place that north arrow in that file, come back to your reference file, and automatically that north arrow is going to be at the right bearing. Also, basics, plan development. I'd highly encourage you guys to take a look at the example set of plans that's on the state website under resources. It shows you everything that a plan sheet should look like. Make sure you set your annotation right. This was a 20 scale. So there's 20. I probably want to go through, I want to dimension on every sheet the width of the pavement, the width of the shoulder. I want to label the basics. I want to label any work that I'm doing. My shoulder work, my ag shoulder, my proposed culvert. If you have any detailed sheets, like on an intersection, you're going to have a blow up of the intersection. You're probably going to place a note that says something to the effect of see page something or other for more intersection detail information, that sort of thing. On some jobs, you'll have pavement markings. They may be in a separate file. They may be in this file. Typically, on a job like this, we would probably not have separate pavement marking details. It's really just the urban jobs that we have pavement marking details, and usually those are separate sheets. In a case like this, you're going to have a handful of pavement markings that you might want to show, such as the stop bar at the stop sign. And for that, you would not need a separate sheet. You could probably just do that on the regular plan sheet. So anyway, we got as far as we hoped to when we started the class. We went really fast this last section, but hopefully everything we covered today helps you guys, and helps the people listening to the video, all the new employees. So let's end the video there, and somebody else has the room here in a few minutes.
Control 8.
Sorry.